Welcome to Algebra 1, Section 11.5, Solving Rational Equations. Some rational equations are just proportions. Solve them by cross multiplication. Now, since we're dealing with fractions, we need to watch for the denominator equaling 0. So look at your denominators and determine what variables would make that equal 0, and make sure those are listed as what it cannot happen. This is a rational equation that we will solve using proportions. Now, when you do proportions to solve, you can use cross products. So we have 3 times the quantity x plus 2. We know that will equal 4 times the quantity x plus 1. We're going to go ahead and solve this. As you can see, x equals 2. Make sure you understand every step I did. Now I'm going to take that x equals 2 and I'm going to put it back in the equation to make sure there's no extraneous answers, and to make sure that I have done it correctly. Whoops, I made a 3 there. It's supposed to be a 2. So I have 4 over 4 equals 3 over 3, and of course 1 does equal 1, so we know that it's a working solution. Now if my answer had been a -2 or a -1, one of these denominators would have been 0, and my answer would have been extraneous. Here's another example of a rational equation. Now this rational equation has the denominators already equal. So my denominators are equal, although I could go ahead and use cross product, it's not the easiest way of solving this equation. Because my denominators are equal, I know my numerators must be equal as well. I'm going to go ahead and solve them. Solve for the x, the unknown, and find out that x equals 3. Check my answer by sticking it back in to make sure that I did the things correctly. And you see that I did, and my answer is not extraneous. And here's a third example of a rational equation. Now I've got some decisions to make. I can go to make it a proportion and then use cross products, or I can try to get a common denominator among the 3, and then I'll have the numerator. I honestly think the common denominator is probably the best and easiest way of going here, so let's go ahead and try that. So they're all going to have 12x in common. So to get x to be 12x, I'm going to multiply by x. So I'm going to do that to the numerator. To get 2 to be 12x, I'm going to have to multiply by 6. So you do that to the numerator. And to get 3x to be 12x, I'm going to multiply by 4. So again, I'm going to do it to the numerator. Now that I have my denominators the same, I know that my numerators have to be equal as well. So I have 5x minus 6 equals 4. Go ahead and solve for that. So 5x equals 10, which of course means x equals 2. Now I'm going to check it. So I have 5 over 12 minus 1 over 2 times 2 equals 1 over 3 times 2. So 5/12 minus 1/4 equals 1/6, and of course I need to make a common denominator here. So 1/4 will become 3/12. 1/6 will become 2/12. So 5/12 minus 3/12 does indeed equal 2/12. So I do know that these are correct. So my answer is x equals 2. Here's another problem to work through. If you feel you've got a handle on this, please take a moment, pause the video, try to do the problem, then check back in. My common denominator here will be 3x. Multiply this by 3x. So it'll be x over 3x. Multiply this by 3. So it'll be 9. Multiply this by 3 as well. So I get 6. So now that my denominators are the same, I can kind of ignore them and work just with my numerators. So x equals -3. I'll go ahead and check this. So I have 1 over 3 plus 3 over -3 equals 2 over -3. I have to have a common denominator, so I'm going to make both these negatives. So I have a common denominator. And of course, yes, it does. -1 plus 3 does equal 2. So far you've seen two ways of solving rational equations. One method is to look at it as a proportion and use cross products. And the second method is to get a common denominator. I think you'll end up using the common denominator theory a lot more often, but both theories do work. To make 1 into x squared, I have to multiply it by x squared. So when I do that to the numerator, I get x squared over x squared. To get x to be x squared, I multiply by x. So I'm sorry, my numerator, 1 times x is x. And of course, this I just multiplied by 1, so I'm just going to leave it alone. Make it 12. My denominators are the same, so I can focus on my numerators. X squared minus x equals 12. Get them all on one side. Whoops, I forgot something there. I subtracted 12 from both sides to get that. Do my factoring because I have a squared here. That means I have two possible answers. So if x minus 4 equals 0, or x plus 3 equals 0, in this case x must equal 4 for this to be true, or x equals negative 3 for this to be true. Those are my possible answers. Put them back in. 1 minus 1 over 4 equals 12 over 16. Well, this would be 4 over 4, so 3 over 4 equals 12 over 16. That is true. For my second one, I have negative 3 over negative 3 minus 1 over negative 3 equals 12 over 9. These become positive. These become positive. So it looks like I have 4 over 3 equals 12 over 9, and that is true as well. Bring any questions you have with you, and I will try to answer them tomorrow in class. See you tomorrow.